So I know that you've been at the fair for a number of years now. You said this was your third year with us?
Yeah, that's correct. It's the third year we're here.
All right, but for those people who are not familiar with this company, I was wondering if you could just start by giving a brief rundown of who you are, when you first started coming around on this scene,
Yep.
and just let us know.
Okay, so basically the company is a Danish company. It started in 2007, and as the name says, green hydrogen, we have been focusing on using renewable energy to make hydrogen from the start. And we do that basically on an alkaline system that is pressurized, and we've been doing that since 2007.
Okay, so you use an alkaline system. The alkaline electrolyzer, could you tell me a little bit more about that? What sort of use cases would you use for that pressurized system?
Okay, the pressurized system, the alkaline has been around for many, many years. So that's why we just wanted to take it to the next level. That means make it smaller. That means you have to pressurize it. So it comes out now at 35 bar directly, but still remain the long lifetime of the alkaline system. So we have like a plus 10 years lifetime, which makes it more utility grade equipment. And at the same time integrate dynamics in the alkaline, which has normally been a problem to be dynamic. But since we've been working on that since 2007 as the first objective in the company, we have achieved to do that. So we have, let's say, a system that is as dynamic as a PEM system today. And actually we also have a small PEM system in the house, so we know both technologies, because of course you have advantage in both technologies, but we see clearly that today that the hydrogen produced by alkaline, we reach a much better price, which again is more important to have rapid return on investments.
And why is it that the alkaline electrolyzer gives you a better price on hydrogen? Is it just purely an efficiency and durability question?
It's the combination of CAPEX and OPEX. So first of all, it's relatively inexpensive compared to other technologies to produce. You don't have a lot of rare materials in it, so it's very limited. We do not take any scarce resources on Earth to produce it, which also makes it more scalable to scale up in production. It's not really that complicated when you know how to do it, but it's working well, and we have done everything using existing industrial materials to integrate into our system, so we do not special develop too much. If somebody already exists and it works, okay, let's bring it in, let's bring it on board, so we can have the capex down on the system, and at the same time, with the long lifetime, we can keep the opex at a very reasonable level, and those two in combination with high efficiency gives a low price per kilo of hydrogen.
Okay, I understand that. So, although you said you also produce PEM electrolyzers, so presumably, despite the advantages in terms of cost and durability of the alkaline, you do see a use case as well for the PEM within your own company even.
Yes, we do. Let's say the alkaline starts from 65 kilos a day and upwards, where the PEM system we have is a 1 normal meter cube, so it's a 2.2 kilos a day only. But there's a lot of applications in remote houses. Could be in industrial production somewhere. It can be in also what we see a lot of universities. Universities need the technology because they need to train a lot of people. We need to have more trained people from coming out of school, and we see a lot of needs for this applications in this area.
Okay, so I have a little bit of trouble visualizing what 2.2 kilos of hydrogen per day can actually get me. Is that the sort of size that I'd be using for like a single family home if I was to be doing that? Or could you put a little bit of a more user-friendly term for that?
Yeah, well, you can say basically on 1 kilo, if you wanted to run on it, you can drive 100 kilometers in a, let's say, standard car. But if you want to do the energy storage for, let's say, a remote house, you would need to store that energy for produced in summer and then consume it in winter to do electricity and heat. And here, let's say 1 normal cubic meter would probably be enough, all depending on where you are. We got some projects called Zero Sun, where you actually have no sun in the winter. So it still works for one family houses in those areas.
Okay, so it sounds like when you're talking about houses in fairly remote areas, this would be a perfect example of hydrogen produced on site, which is something that, of course, with the topic of your talk, is something that you feel quite strongly about as being a a strong option for hydrogen production. But despite that, there are, of course, some limitations with fluctuating power needs. Can you speak a little bit to why you feel that locally produced hydrogen is really the way to go?
Let's see, when we look at the production price, we think we base it on a standard price of 40 euro per megawatt hour. We include all the maintenance, the operation for 10 years. We reach a production price about 3.5 euros per kilo of green hydrogen produced from renewable energy. And this is very competitive and can actually be used everywhere. And it avoids the need to transport hydrogen, because we all know that the need to transport hydrogen, that's not for free, and it's very seldom done on a, let's say, completely green way as well.
So you said it was around, three...
3.5 euros per kilo of hydrogen produced on site, for instance, for industrial use, or it could be used for refueling stations that you have everywhere.
Okay, and do you have any sorts of comparative prices for whether I was to do a centrally produced hydrogen and send it out? Of course, this will vary dramatically depending on how I've made my hydrogen and where it's going, but sort of, you say that it's very competitive.
When we look at the market prices for centrally produced and distributed, of course it depends on how far you have to distribute it, but if we base it just on the same 40 euro per megawatt hour for the electricity, we end up at a price at the customer of a little less than 6 euros, where ours is 3.5 delivered on site, and it's green.
So the majority of that is then associated with the transport costs?
Part of it is associated with that, but we have just a very efficient system as well, so we have high efficiency, and thus our production costs are also getting quite low.
Okay, so assuming that you're using the same system, and aside from the transport costs, what are the benefits of producing locally?
Well, the benefits of producing locally is also that you have less people involved in it. In actually production or in transportation, but you will have more people involved in, let's say, the local area. You'll have the ability to create some local ecosystems where you actually build up a complete ecosystem around it, where you'll have people to install it, to maintain it, to operate it. The hydrogen that you produce locally, you can start supporting new business that can work with fuel cells, or making tractors that runs on hydrogen, making power backup. You will be able to foster a new series of new companies that can grow up around it when it's local, instead of making everything centralized, where you, let's say, like in the fossil days, we had to put everything in a refinery and then distribute it. We don't need that to do this here. We can let the energy transport itself in the wind and in the sun, and then it comes to any remote village or area, and then you produce locally there instead, and create actually wealth and prosperity for the local community, instead of just paying for the diesel or the gasoline that is getting delivered.
Okay, so you're improving the local conditions by having people on site, but you guys at Green Hydrogen, you make an electrolyzer. You don't make the company. So do you aim to be getting local partners, or are you aiming for larger corporations that then will outsource that? Ideally, what sort of partnerships do you look for?
So ideally, the way we work and the way our strategy is to work with partners, and we want local partners. Because again, this is will be, let's say, a running system, and it'll need to be maintained. It needs to be local. You need local support. You need local build-up. You need local knowledge. So it's local partners that we want to find. If some big ones want to distribute it everywhere, it's okay. We have no problem with that. But mainly we see niche system integrators in the field that we work with, that take us as, let's say, basically one brick in their solution, and then they create a solution around our basic brick.
Okay. And is there certain local partners that you think is better or potentially less well suited to your technology? What do you look for when you form these partnerships?
Well, the partners, of course, has to be understand the benefits of hydrogen and hopefully be a visionary on that. But companies that are like, for instance, the wind turbines have knowledge of this, because you have some of the same things in hydrogen. In electrolyzers, we have some high pressure, you have some high voltage, you have some things to operate that needs to maintain. These has natural skill sets to develop, let's say, a hydrogen section on their current wind turbine activities. As well, the PV can also be a natural plus for them. as well as electricians. Electrician companies that work today, many years ago, they had no fueling or recharging point for electric cars, but you see all of them coming in this business now, expanding the business, and this will be a natural extension also to them to go into this.
Okay, so you mentioned the electric business and different energy needs depending on the partner that you are working with. How does green hydrogen handle the differences in scale? Like, can you go quite small needs as well as quite large?
Yeah, so the system is it's a modular scalable concept. So you can start, let's say, basically the smallest one is 65 kilos for utility grade equipment, and then you can go up to several tons or megawatt as you want. It's just building blocks that are complete building blocks. They have both the dry and deoxide inside, so it delivers clean green hydrogen out of the unit, and then you just put, if you need double capacity, you put 2. If you need redundancy, you can do an N+1. It's quite easy to build. It doesn't take much to actually do it.
Okay, so you guys easily do the megawatt level. I know it hasn't totally been done yet, but lots of people are talking about possibly doing more on the gigawatt sort of scale. Does green hydrogen have any interest in getting into that sort of market, or would you prefer to keep it a little bit smaller?
What we want to do is to follow the market development, where there actually is some business. We have a high focus on making business, making return on investment for the investors that invest in it. And where we see the market today is mainly the transportation sector, and the energy backup is also getting more and more. And those sectors are not necessarily in the megawatts, because if you produce distributed, we end up having mega or gigawatts, but it will be distributed around in the country, so we will produce and consume the hydrogen locally. That being said, we are of course looking at making bigger building blocks. The building blocks that we have today is the biggest one is 2 square meters, is 200 kilos per day. We want to, let's say, make them bigger, make them double or triple, but we still want to keep the modularity, so it's easy to build also the N+1 redundancy into the system and actually produce and consume locally wherever it's needed and not centrally and then distribute.
Okay, so while I like the idea of the produce and consume locally concept, something that's definitely an advantage for more the central side is the ability to have experts on site all the time, as well having monitoring there, and you have your experts, so if anything goes wrong, somebody can respond quite quickly. Do you have any solutions put in place for this? I assume that not every community that wants their own green hydrogen solution has an expert living on site.
Not yet. But of course there's systems, so you can do the remote management like everything else. You'll get the alarms, you can manage it from a management center centrally. But again, having partners that are locally, those are the partners that will intervene as the first level. So we also, part of it is a lot of knowledge transfer from us to our partners, and actually from the partners to the one that will operate the stations. It's all about getting the knowledge spread out. We don't want to sit on the knowledge, we want to spread it out, so it also helps create this eco-society, that people can actually work with hydrogen in the local society, because more and more people locally will have knowledge about it and can see new applications. If I could do this, I could do that. So we will create more and more people. But remote management is clear that it's a must. So it's there, it's a standard, it's a new modern product. It's not old-fashioned, there's no valves to turn, everything is controlled remotely. So it exists, but it still also supports the building up of an ecosystem on hydrogen for local partners.
Okay, so while you can monitor it, and presumably the partners can also monitor it, the idea basically is that the locals on site will have the knowledge and expertise to fix anything that might come up.
Not fix anything, but let's say...
Not anything, most things.
Most things,
expected things.
Yeah. The usual things that will be defects, of course they can change that. There's you have basic things like you got water treatment, and water treatment needs to have changed the filters. So basic things they will be able to do. But of course, if there's a compressor that's on site that you need to change the piston or something, that will be a little bit more complicated. You'll need more skilled people. So there will be different levels, and partners will also be trained in different levels, so they can do more and more.
Okay, and for your remote monitoring, does it have the capability to diagnose what the problem is, so that whichever technician you might send out knows exactly what they're trying to replace, or is it a little bit going in blind?
No, we are pretty much able to determine where we expect a problem to be by remotely diagnosing and communicating with the sensors. And this goes globally because we are starting, but we have projects more or less globally and are waiting already. So everything is need to be set up in a good way from day one. So you send the right person to the right site with the right equipment at the right time. Also, preventive maintenance, of course, is a part of it, but it's very important to keep the operating costs down, that you do not waste your time sending 3 technicians with the wrong screwdriver.
Right, of course. So you mentioned that you have projects worldwide. Could you give an example of maybe one of your favorite projects that you have going on at the moment, you're already involved in?
Yeah, so I think probably one of the best one right now is a nice project in Sweden where we do energy storage. So it's 172 apartments that will go completely off-grid. So they will do that by producing with solar panels. They will produce the energy in the summer, store the hydrogen, and then in the winter you would go back and take the hydrogen, convert it using fuel cells to heat and electricity. And this is a, let's say, real life-size project because we have done that also other places for one house. But this is the first time that it's really being done with our partner, because the partner is doing all the management software to control and the storage. We just basically deliver the engine to produce the hydrogen.
Okay, that's really interesting. So 172 off-grid apartments in Sweden. That's pretty fun.
Yep.
At this point, I'd like to see if the audience has any questions. If you do, feel free just to toss up your hand and I will bring the microphone down to you. And if at this point we're feeling a little bit quiet, that's all right. So I was actually just still wondering, though, if people were a little bit tired after lunch and weren't paying as close attention as they maybe needed to or maybe should have, if you had one major takeaway from this, what would you like the audience to really go home and remember?
I would say that a part of a motto is to produce and consume locally. Think about that.
Produce and consume locally is right in the title. We've heard many advantages to it. All right. Well, I think that pretty much covers that. If you guys do come up with any other questions, I'm sure you'd be more than happy to chat with them. Yeah. And you are at booth D69, which is literally right there. So feel free to take a little adventure that way and chat a little bit more about particular hydrogen needs, or as well, are you looking for partners at the moment for local
stuff? Yeah, good partners.
Good partners. All right, well, then if you think that maybe you might be a good partner, head on over there. All right, thank you so much for your time. Welcome. I hope you continue to enjoy yourself here at the Hanover Fair 2019. Thanks so much.
Thanks for having me.